Hi everyone. My name's Atharva, and alongside Mason, Lucy, and Catherine, we make a mobility PEI, so the Pedestrian Environment Index. A quick outline of what we're going to be talking about today. So, firstly, why we even care about walkability. Secondly, why we're creating a new walkability model. Then how sort of PEI, so our model scores walkability. And then a quick run through of what we accomplished this semester, and sort of looking forward to next semester too. Catherine's going to quickly talk about why we even care about walkability.
So during COVID, studies linked walkability to mental health patterns, showing that access to more walkable areas is associated with better health outcomes, physical activity, and even equity. And that research is what motivated us to build our own walk score. Overall, it's important for urban planning, public health, and sustainability, and it supports active lifestyles, reduces car dependence, and lowers environmental impact. But with all this research, there's not really one agreed upon way to quantify walkability. There's limited public resources that lack transparency on how it's measured. So right now, the walkability standard is called Score, and it measures walkability mainly based on how close you are to amenities. And while distance to these amenities definitely matters, it's not the whole picture. And I'm going to hand it off to Lucy to talk a little bit about how Walk Score can get it wrong.
So as you can see here, the walk score rating for this location on Virginia Beach Boulevard is pretty high, and walk score labels it as very walkable. However, when we go to look at this location on Google Maps Street View, we see that it's a big highway and it doesn't really match the very walkable rating that was given by walk score. This led us to identify a gap that exists. Walk score is an outdated standard for portraying urban walkability. We realize that there is room for new technology to improve how we calculate walkability of cities by taking into account additional factors, which led us to our pedestrian environment index. It combines a multitude of different factors such as commercial density and population density to calculate walkability. And Atharva is now going to talk about how we calculate PEI.
Now let's talk a little bit about PEI itself. The original PEI was actually came up with by the University of Illinois, Chicago. They came up with a PEI metric which uses population density, intersection density, land use diversity, and commercial density as four sub-indices to create one whole PEI. Looking into how we sort of recreated their research paper, we used two main APIs. So we used OSM data, which is OpenStreetMap data, by the Overpass API. So that's sort of for commercial points of interest and general points of interest like roads, parks, restaurants, etc. And then for population data, because it's not in OSM, we have to use a census API. Moving on to quickly running through each of the sub-indices. So population density index is pretty simple, just a population of a tract divided by the area of the tract. Commercial density, bit more complex, but pretty simple. We add up the count of commercial points of interest, stuff like restaurants, cafes, schools, banks, etc. Divide that count by the area of the tract to get commercial density. Land use diversity is a bit different. So again, it gets all these sort of points of interest or different kinds of land use. And it calculates something called entropy, which is essentially the variance in the different kinds of land uses within a tract, or the different kinds of variance, the different kinds of points of interest within the tract. And a higher entropy value equals a higher land use diversity index. Finally, intersection density index. So the Overpass API allows you to look at roads and highways as nodes and ways. And if you count intersection between these, you can get a count of intersections within a tract. If you divide that by the area, you can get intersection density index. Finally, after we get the four sub-indices, we normalize all the data on a scale of 0 to 100 or 0 to 1 percentage-wise across the whole US. So each of these four sub-indices have a nice sort of 0 to 1 or 0 to 100 score. And then we plug that into this PEI formula from within the University of Illinois paper to get a PEI for a tract. Now we're going to quickly talk about, or Mason going to quickly talk about a quick summary of previous semesters.
Yeah, so we actually created PI, but what did we do with it beyond that? So the first thing we did was create a web app, as you can see on the top right, which is basically a way for us to visualize the PEI data that we created across all 3 years. And then in addition to that, we actually worked with Dr. Koo, who is a professor at Emory, who kind of works in the link between neighborhood factors and mental health. And so for him, we created nationwide PEI data for his research, which we'll talk about later. And then in addition, we created an additional transit subindex, which is essentially an index that measures how accessible transit is to a given area. And you can kind of see the transit index on the left here and all of our nationwide PEI on the right. And then, so that's what we did in previous semesters, but what did we accomplish this semester? And I'll let Lucy explain what she did.
So this semester, I worked on developing an index to add to our PEI calculations, and the index that I worked on was the Road Safety Index. I first started by looking into research, and the research that I found indicated a strong correlation between road speed limits and pedestrian safety, which I realized ultimately impacts an area's walkability. So I became interested in quantifying how walkable an area is based on the speed limits of its roads. I use Nielsen's bar model, which correlates the changes in traffic speeds with the changes in road crashes to obtain safety scores for each road. I then weight each road score by the length of the road, so longer road segments will count more towards the overall block group score. OpenStreetMaps lacked a comprehensive data on the speed limits of roads, so I decided to take more of a policy-driven approach, looking at each state's legal documentation of speed limits and matching that with the roads based on OSM tags. And here's a visualization of walkability in Atlanta based on my road safety index. I've highlighted a few of the safest block groups by my calculations, and they all show small roads with lots of greenery.
I also added a sub-index to PEI called the Social Green Space Index. This index started as an idea of a broad environment index monitoring factors from tree canopy coverage to climate to air quality. As on the right, you can see some of the initial CDC data I looked at across urban areas, suggesting that walkability might be worse where it's harder to breathe. Then I decided to switch my focus to man-made social green spaces like sports fields and dog parks because it more closely indicates walkability, meaning like the more outdoor spaces people have to gather in, the more walkable the area must be. Then to obtain the data for this, I also used OpenStreetMaps, querying some of the tags I mentioned before, like parks and playgrounds. As you can see on the Atlanta trial on the right, I created a function to track all the polygons of green spaces, and you can kind of see Piedmont Park highlighted there. In my chosen methodology, the social green space is scored as a measure of the area of all green spaces over the total area of a tract. And finally, there are some limitations I would like to dive into still next semester, namely completely verifying the overlay function, improving upon efficiency as all those polygons create a lot of data to track, and also looking into the original environment index idea and comparing it to my social green space results. In my visualizations from 2013 to 2022, you can still see that according to Social Green Space Index, Atlanta has gotten more walkable. Now I'm going to hand it to Mason to talk about what he did this semester.
Yeah, so this semester we really focused on creating more unique indexes to sort of make PEI more robust. And so another one we looked at was how bikeable an area is, because research has shown how that's an important aspect to a good urban design and environment. So we created the bike index, and similar to our other indices, we queried OSM for bike infrastructure data, as you can see on the top right here. And then after doing that, the next step was to categorize infrastructure, because not all infrastructure is the same. For example, you could have a separate bike lane or just a painted or shared road bike lane. So not all bike lane infrastructure is created the same, and some might mean more people want to bike than others, so it's important to categorize. And then after that, the calculation is just finding the distance weighted by the category, and then summing that up, also weighted by the area. And then that generates a bike index, as you can see on the right. And this is sort of, we were able to visualize bikeability across the 3 years that we also created PEI for. So you can see how bikeability has kind of changed in Atlanta over time. And then if we analyze that further, I actually created a percent change sort of to visualize how bikeability has changed in Atlanta. So the red means a greater percent change of bikeability. And that actually maps out perfectly with sort of how the Atlanta Beltline and other bike infrastructure initiatives have increased over time. And so you can see that represented in the image as well. And so I'll hand it over to Tharva to go over what he did.
Yeah, so a couple of things on the web app. So you saw we already had a web app, but we wanted to add some changes. So the first thing that we did was add this concept of a slider. So on the bottom right, you can see on the web app, there's different sliders for each of the metrics or the sub-indices. And that's really just because, different researchers may have different priorities. They may care about different things. So for example, if you care more about commercial density, you can increase the commercial density slider, and the PEI score will dynamically adjust and show you that on the image. We also attempted to sort of add nationwide data to our web app, currently just Atlanta. The issue with nationwide data was that, the files are extremely large. So we tried a few different methods such as vector tiling, but none of it really worked as nicely as we wanted it to. So that's definitely something we're going to look at for next semester. Moving on, we have some really promising results from Dr. Koo's findings. So I know Mason referenced that Dr. Koo sort of works at the intersection of, urbanism, walkability, and how that links to mental health. And as you can kind of see on the image there, he ended up finding out that there was a really strong association between census tract level PEI and sort of mental health issues, even after adjusting for stuff like age, sex, race, ethnicity, etc. So that's really promising. And then sort of adding on to that, another thing we did for Dr. Koo was to create this neighborhood matching tool. So essentially, this tool allows researchers to add neighborhood features such as PEI to their participant datasets without exposing sort of personal health information. So we have a really easy sort of pip installable function that people can import and then use. And yeah, so we do have we also have a pretty short paper coming out, hopefully, that kind of just outlines this whole process. So yeah, all interesting stuff. Yeah, I think Mason's now going to quickly talk about next semester and what we're going to do.
Yeah, so this semester, again, we focused on creating new indices. So the next thing we need to do is actually finish up and include these indices to fully integrate them into PEI. So steps for that will be in processing nationwide data for historical years, and then being able to integrate that with PEI. And then also we'll continue to work on more indices such as an environment index that Catherine mentioned, just to make PEI more robust and more configurable to how or what people want to focus on. And then with that, we also want to update our website to be able to visualize nationwide data. I know Atharva mentioned how we had been trying to do that, but we still need to make the web app just more interactable and more complete. And then also there's other features we'd like to add, like a city comparison tool. So you could take two different cities and sort of be able to compare what the walkability score is in that given area. So that's what we'll prepare for next semester. But that'll be it for our presentation. Thank you. And if you have any questions, please let us know.
Thanks, everyone. Thank you this was an amazing presentation, and thank you for staying exactly on time.